The experiment, discovery of the electron. Thomson developed his atomic model after a series of experiments with a cathode ray tube in 1897. Apparatus. A cathode ray tube is a sealed glass vacuum tube with two electrodes, a negatively charged cathode and a positively charged anode. Procedure: Thomson applied a high voltage across the electrodes, causing a glowing beam to be emitted from the cathode. These were called cathode rays. He performed three main experiments to investigate these rays: magnetic and electric deflection. Using both a magnet and an electric field, he deflected the rays. The beam bent toward the positive plate, which confirmed the negative charge of the particles. Mass-to-charge ratio. By measuring the deflection with varying electric and magnetic fields, Thomson calculated the charge-to-mass ratio of the particles. He found that these particles had a mass thousands of times smaller than a hydrogen atom. Conclusion. Thomson concluded the cathode rays were tiny, negatively charged subatomic particles he called corpuscles, now known as electrons. He realized these particles were a fundamental component of all atoms, disproving the theory that atoms were indivisible. The concept of Thomson's atomic model. To account for the electron and the fact that atoms are electrically neutral, Thomson proposed his plum pudding model. Structure. An atom is a sphere of uniformly distributed positive charge, embedded electrons. The negatively charged electrons are embedded within this positive sphere, like plums in a pudding. Electrical neutrality. The positive charge in the sphere is equal to the total negative charge of the embedded electrons. This cancels out the charges, making the atom electrically neutral overall. Stability. The model theorized that electrons are held in place by the electrostatic attraction of the positive sphere. Example: the watermelon analogy. A common analogy to explain the model is a watermelon. The red flesh of the watermelon represents the atom's sphere of uniform positive charge. The dark embedded seeds represent the negatively charged electrons scattered throughout, limitations of the model. Although revolutionary, Thomson's model was short-lived because it failed to explain later experiments. Rutherford's gold foil experiment. In 1909, Ernest Rutherford conducted an experiment that contradicted the plum pudding model. He fired positively charged alpha particles at a thin sheet of gold foil. According to Thomson's model, the particles should have passed straight through with minimal deflection. However, Rutherford found that while most particles passed straight through, a small number were deflected at large angles, and some even bounced back. Conclusion of Rutherford's experiment. This proved the positive charge in an atom is not spread out, but is concentrated in a tiny, dense core, which he called the nucleus. Rutherford's work led to a new atomic model that replaced Thomson's.